I'm going to spend some time today reviewing solving equations and simplifying radicals. These are some key concepts that we need to actually know how to do when we are focusing on geometry. So the way I usually do my notes is I usually try to highlight the things that stand out to me or the things that are important. So when I am using these notes to study or to help me do my homework, usually my eyes are drawn to the colors first. So I always highlight my title. So I recommend that if you don't have a highlighter, you might want to get a couple colors out or different colored pens, just so you can start getting familiar with the way that I take notes in my classroom. So if you need at any point to pause this video, you're more than welcome to, and that way you can go at your own pace. So when solving equations, we're going to talk about solving equations on the front, and then on the back we're going to talk about simplifying radicals. So we already talked about solving equations a little bit a couple classes ago, but we're going to talk about it again. And we have a goal when we're solving equations. So the goal when we're solving equations is to isolate the variable. So my handwriting is a little terrible on this too, so I'm sorry. To isolate the variable. At any point you can't read my handwriting, just come and ask me, but it's just because I'm writing with a stylus and it's not the best. So my goal is to isolate the variable, which means to get it by itself, okay? So you have two examples. So if I real quick do the first one for you, or with you, first thing I'm going to do is I'm going to distribute. So I have 2c minus 12 equals 9c plus 16. So now I'm going to subtract 2c on both sides. So I have negative 12 equals 9c plus 16. So now I'm going to subtract 16 on both sides. So now I have 9c equals negative 28. So now I'm going to divide by 9. 28 divided by 9 doesn't work, so c equals negative 28 divided by 9. And I'm done. So go ahead and try the second problem, and then I will check your answer when I tell you to come up and show me your answers on this video. But make sure you pause it, because I'm going to keep going. So if you look at these bottom 6 problems, they all have fractions. So what happens when I have fractions? Your Algebra 1 teacher has taught you this in a bunch of different ways on how to solve these types of problems. No one way is the best way. I'm going to show you maybe a couple ways, and then you can choose how you want to do it. But your end goal with fractions is whenever we see a fraction, we usually get scared. So whenever you have a fraction in an equation, I try to simplify that fraction to ensure that it's gone. So how do I get rid of, so what happens when I have fractions? I try to get rid of them by making equivalent statements. And how I make equivalent statements is I multiply the entire equation by the denominator. So if I look at this first example here, notice I have fractions. So if I don't want to deal with these fractions, then I'm going to multiply this whole equation by the denominator, and the denominator is 3. So I'm going to multiply the left side by 3, and I'm going to multiply the right side by 3. And again, this is just one way to do it. So if oops, and I wrote 4 on the other side, didn't I? That's right. Oops, and now it's not in red. Hold on, sorry. Okay, so if I clean up the right side, 4 times 3, that's 12, that's easy. So now I'm going to distribute this 3 to both. So if I multiply 3 times 2x over 3, these cancel out, so I'm left with 2x. And if I multiply 3 by x over 3, those 3's cancel out, so I'm left with plus x. So now if you look at this equation, it's nice and easy. 2x and x make 3x. So x equals 4. Remember last class I told you I'm okay with you skipping steps, as in not showing your work by writing this divide by 3. But if you are prone to making careless mistakes, I strongly encourage it. So another way you could have done this problem, if I erase it, is you could have said, well, those two fractions have the same denominator, so I can just add them up. And I could say, well, 2x and x make 3x over 3 equals 4. And then I know 3x over 3 just makes x, so x equals 4. So that's another way you could do it. So I'm going to allow you to try number 2 on your own. So I'm just going to circle that so you know you have to do that one on your own. So you can pause this video and try it, and then come get it checked by me, or you can wait until the end. Number 3 I'm going to jump to. When you have to distribute a fraction, you have a couple choices. You can either distribute fractions and do fraction math in your head. So 1/2 times 2x, so that's just going to be 2x over 2. And 1/2 times -4, that's -4 over 2. And then you could simplify all of that. So 2x over 2 is just x. And -4 over 2 is -2. And that equals 6. So now add 2 to the other side. X is 8. Another way you could have done it is if it didn't, you could have just said, well, what's half of 2x? That's x. And what's half of 4? That's 2. So you could have distributed it completely in your head. Or I do what's called the over 1 trick. Helps my brain. So I multiply the top with the top and the bottom with the bottom. So if I distribute 1, I have 2x minus 4 on the top. And 2 times 1, I have 2 on the bottom. So that's 6. So now I'm going to do the exact same thing. I'm going to get rid of fractions by multiplying both sides by 2. So these cancel out. So I'm left with 2x minus 4 equals 12. So now I'm going to add 4. I get 16. So now I'm going to divide by 2. X is 8. I'm sure there's probably a couple of other different ways you could do this problem, but that's just another way to do it. If I jump over to number 4 is a little different because I have to distribute with a fraction inside. So if I distribute 4 to 2y, that's 8y. And then 4, half of 4, well, that's 2. And that's going to equal 6. So go ahead and solve that problem from there. So now I'm going to have 8y equals 8. So y equals 1. And then, if we look down at number 5, when I have a fraction equals a fraction, you have a couple choices. What I would do is I would cross multiply. It's the easiest way. So it doesn't matter which method which diagonal you do first. So if you want to do this diagonal first, 3 times x is 3x equals 2 times 12 is 24. So you're basically making your pretty butterfly. It doesn't matter which diagonal you do first as long as you put 1 on the other side of the equal sign. So if I solve for x, x is going to equal 8. So if I preview over to number 6, I have to cross multiply 4 times 2x, and then I have to cross multiply 5 to x plus 3. So is that 5 being multiplied to x? Is it being multiplied by 3? Or is it being multiplied to both? It's being multiplied to both. So I want you to go ahead and do this problem. So when you finish number 6, you're going to bring this paper up to me so I can check 6, 2, and then the number 2 up at the top of this paper. Hopefully you've already had your front side checked. If not, make sure you bring it to me to get checked. But now we're going to talk about simplifying radicals. So the first question that I always like to talk about is, what is a radical? A radical is just a fancy word. It's a fancy word for root signs. So square root, cube root, fourth root, fifth root. It's just a fancy word for a root. So this was everybody's favorite lesson in Algebra 1. Everyone got them right all the time. So how do we simplify them? Your Algebra 1 teachers usually taught you one way, but some of your Algebra 1 teachers might have taught you both ways. The first method is the one that I know everybody learned. It's by prime factorization. It's breaking your numbers out. That's the longest way. The quickest, best way is using perfect squares. Some teachers showed this to you, some teachers didn't show this to you, and that's totally cool. Prime factorization is awesome because it works 100% of the time. Using perfect squares requires you to do a little bit of more mental math. So we like to teach you prime factorization because it's foolproof. It's going to work all of the time with minimal thinking. Using perfect squares takes up a decimal of the time. So you all are going to feel very comfortable using prime factorization, but I challenge you to try to do these with perfect squares. So let's go ahead and let's do number 1, square root of 50. I'm going to do prime factorization first. This is where I do my factor trees. Two numbers that make 50, 25 and 2. 2 is prime, I circle it. That branch is dead. Factors of 25, that's 5 and 5. 5 are both prime, So now I write run radical house, and I put 5 times 5 times 2 inside. In order for numbers to break out of my radical house, I have to have a group of 2. So my 5s have a group of 2, but my 2s are not a group of 2. So 2's stuck inside, 5's stuck, but 5 gets to break out. So with my 2 5s, one 5 escapes, the other one gets caught and goes away. So 5 is now free, but 2 didn't get to break out with anybody, so 2 is stuck inside. So that's the way you do it with method 1, which is prime factorization. So now, let's talk about perfect squares. Perfect squares. I'm going to write all perfect squares on my corner side of my paper here. So I'm going to write 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81, 100, 121, 144, 169, 14 squared, 196, and then I could keep going, but I'm just going to stop. Okay. So I want to find the biggest perfect square that goes into 50. So I'm going to look on my beautiful perfect squares, and I'm going to find where 50 would fall. 50 would fall somewhere between 49 and 64, correct? So that means I can only ever use potentially one of these numbers to be the biggest perfect square. So if I do 50 divided by 49, because that's the biggest perfect square, that's smaller than that actual number, I'm going to get a decimal, right? 49 divided by 50 is 0.98. That's not going to work. What about 36? So if I now try 36, 50 divided by 36, that's 1.3888. That's not going to work. I get a decimal. So now let's try 25. 50 divided by 25, hey, that's 2, which means 25 is the biggest perfect square. So I'm going to write 25 and 2, because that's that factor tree. Square root, square root. So what's the square root of 25? It's 5. What's the square root of 2? It's a decimal. I don't know. So that stays inside. I'm done. And look, that is the exact same answer I got was doing prime factorization. So let's go ahead and let's do number 2, which is the square root of 48. So 48, if I can erase some of this. Hold on a second. So 48, let's see where 48 would fall. 48 falls somewhere between 36 and 49, which means I can only use these numbers up here that are my perfect squares. I always start from the biggest number and work my way up because you're looking for the biggest perfect square. So can 36 go into 48? No. Can 25 go into 48? No. Can 16 go into 48? Yes? 3 times. Bingo, done. 16 and 3, square root, square root. What's the square root of 16? 4. What's the square root of 3? Square root of 3. Hopefully you're seeing this as a little bit easier. Again, I challenge you to try doing it this way. Everybody's really awesome at prime factorization. However, in geometry, we're going to have to be able to do this after we already get our answer. So you don't want to have to take double the amount of time simplifying. Is it wrong to do that? No, you are 100% able to do whichever method you would like to do. I'm just encouraging you to try to be faster if possible. So let's go ahead and let's talk about number 3 when I have variables. So I'm going to do this the exact same way, but I'm going to first only focus on 72. So 72, I'm going to find the biggest perfect square that goes into 72. So if I come back up here, and I'm going to write on my perfect squares red, 72, no, I'll actually do yellow. 72 is somewhere between 64 and 81, so that's everybody up here. So I'm going to first try 64. Can 64 go into 40? 62 go into, if I can speak, 64 go into 72? No. How about 49? 72 divided by 49 doesn't work. 36. 72 divided by 36? Yep, that's 2. So, done. 36 and 2. Square root, square root. Square root of 36 is 6. Square root of 2? Square root of 2, because there isn't a square root of 2. It's a decimal. So now I'm going to deal with variables. Your teachers last year might have made you expand them. X, X, Y, Z, 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 and make you circle all your groups of 2. A square root means 2, so you just take that number and you divide by 2. So if x squared, divide that by 2, so 2 divided by 2 is 1, so 1x is free, the rest are gone. When you have odd numbers, you have to force it to be an even number first, if you can. Since you only have one y, is that going to break out? No, so y is stuck inside. But notice I have 3 z's. If I do z squared and z, I now have an even exponent, so divide that by 2. 2 divided by 2, that's 1, so I have 1 z on the outside. This z is odd, so he stays on the inside. And I'm done. You're going to go ahead and try number 4 on your own, and then you're going to bring it to me, and I'm going to check it. So make sure you go ahead and pause this video. Number 5, when you have 2 radicals being multiplied together, I make one big radical and I multiply them together. 6 times 8 is 48. I need the biggest perfect square that goes into 48. 16 and 3. Square root, square root. Square root of 16 is 4. Square root of 3, can't do. Square root of 3. So I want you to go ahead and I want you to try number 6, and then I want you to bring this to me when you're finished so I can check it.